Good everyone. In today's session, we'll be learning about binomial distribution. A binomial distribution is used to describe a real-world phenomenon where an event results in only two possible outcomes. So we are saying that binomial distribution involves in an event involves in only two possible outcomes, right? And then we say the same event is repeated multiple times. So it involves in two possible outcomes, which means the outcome could be true or false. And then the event, the same event is repeated multiple times. So, for example, let me say we have 20 mangoes and 50 mangoes, and then they said out of these mangoes we select, let me say, three, right? So, what's the probability that three mangoes will be selected randomly from this 50? And then they give another question and they will tell you to select maybe 10, right? So, you are selecting another 10 from this same 50. So, the event is the same, and then the possible outcomes keep on changing or keep on repeating. So, that's what they are trying to say. And then the third one says it describes the distribution of success in a series of a trial. That is, out of n trials, what's the probability that x of them succeed? So out of n trials, so let's assume our n is, let me say, 50. So out of 50 trials, what's the probability that x, which is, let me say, 20, succeed, right? Yeah. So these are some of the characteristics or some of the things that show that we are dealing with binomial distribution. So let's talk about the characteristics of binomial distribution. We said a trial event has only two possible outcomes. It's either you succeed or you fail, yes or no. A trial, there's a fixed number n of identical trial. So in the binomial distribution, they give you a fixed number of series or a fixed number of samples, right? Maybe your n is 50 and you'll be working on that number, right? And then they said the trial of the experiments are independent of each other. So they're independent of each other. The possibility of a success p remains constant from trial to trial. So when they are given in binomial distribution, when you are given a possibility that let me say 50% of a certain number is success, right? So this will be the success for the whole trial, right? Unless maybe they state otherwise. Uh, so when they say if p represents the probability of success, then 1 minus p is equal to q is the probability of failure. So what they're trying to say is that probability sum up to 1. So if p is a success, then if you want to know the ones that are not success or the failure, then it's 1 minus p, right? So our p is success or succeed. So our failure is 1 minus p because probability sum up to 1. So 1 minus p is our failure. So this is what they are trying to say. Example, we are saying that a manufacturing plant label items as either defective or acceptable. So this one example, when you see certain things like this, we are dealing with binomial distribution. It's either this or that, right? So the outcomes are 2. And then the second one says a firm bidding for a contract will either get the contract or not. So it's either they get the contract or not. So when you see certain things like this, you have to know the outcome is 2. So it's binomial distribution. A market research firm receives survey responses of yes, I will buy, or no, I will not buy. The same thing. A job applicant either accepts the offer or rejects it. So these are some of the things that when you see them or you come across, you have to know we are dealing with binomial distributions. All right, so let's move forward. So how do you solve binomial distribution? So we are saying that the formula for binomial, so this is the formula for binomial distribution, which is the n factorial over x factorial n minus x factorial multiplying p x q n minus x. All right, so this portion represents the coefficient of the binomial, right? Normally they represent it by commutative. So let me say n commutative x, where this n represents the sample, and then this x represents, let me say, the success, or maybe the selected variables, right? Yeah. So yeah. So this c commutative, the commutative of n and x is same as this. So you can represent or you can rewrite the formula as the commutative of x and n multiplying px, that's the probability of success, times the probability of failure, n minus x, where this n represent the sample, the x represent the success. So here you can see, you say the n represent the random sample size, the p represents the probability of success per the trial, the q represents the probability of failure, and then we are saying what again, the x, which represents the number of successes when a success is defined as what we are looking for. In simple, so the success could be 1 2 3 0 0 1 2 3 to n, right? So to whatever they want us to find, right? And then when we say n factorial, it means the n minus n, like n minus 1, n minus 2. So assuming we have, let me say 5 factorial, right? 5 factorial simply means 5 times 4 times 3 times 2 times 1, right? Yeah, and then they're saying 0 factorial is equal to 1. So when you type or when you punch 0 factorial on your calculator, you're going to get 1. This formula too, you can punch it on your calculator. The commutative of n and x is on your calculator. I think I will display it on the screen so you will see it how you can punch this on your calculator. Okay, so let me explain what it means here. The commutation of n and x, which represents the n factorial all over x factorial multiplying n minus x factorial. So this n represents the number of the samples space, and this represents the successes, right? So this n here represents the number of the sample space, the success, and then you subtracting the sample space, the success from the sample space, you find its factorial. So assuming the number of the sample space is 50, our n is 50. So here it's 50 factorial over, and let's say our x. So let me write here, n is 50, and our success is, let me say 20. So here will be 20 factorial multiplying 50 minus 20 factorial, right? So let me write 50 factorial here over our 20 factorial multiplying 30 factorial. So in other words, what you can say is that here is the total number of space or the sample that they give it to you. This was success, and this is the difference between the sample and then the success. So you add factorial to it. So when you point this on the calculator, the answer that you get will be the same as you punching our commutative of 50 20. So this also give you the same answer. So let me punch in then tell you the answer. So you have 4.712. Unfortunately, since I predicted the value, it have a lot of zeros, so this is it. And then when you point this one to, you get the same value. It's 4.71. Let me write it here. 4.712 13, yeah. So this is it. So let's move on. So now we know the formula. The formula is, let me write it in short, the commutation of n x multiplying the probability of x kill n minus x, where this n minus x talks about the differences, right? The differences, yeah. So the differences in the sample, like you have 50 and then they selected 30, so the differences is 20. So this represents what is here, and then the q represents our failure, and then we say that failure is 1 minus the probability of success, right? And this is the success. This is the probability of success, or the success. How do you call it? Let me see how they name it. The number of success, right? Yeah, the number of success. So this is how it's simple you can write the formula, right? Yeah. So let's look at this example. They said, if on the basis of past experiences, the store manager of ShopRite at Accra Mall estimates that the probability of a customer making a purchase when he or she enters the store is 0.3. What's the probability that 2 of the next 3 customers will make a purchase? So they said, where should I start? Okay, so let me start again. So on the basis of a past experience, so based on their past experience, the store manager of ShopRite at Accra Mall estimated that the probability of a customer making a purchase when he or she enters the store is 0.3. So which is the probability that a customer will buy something when they enter into the store is 0.3. We know our probability represented by the P. Yeah, right. So the probability that a customer will buy is 0.3. 0.30. What is the probability that 2 of the next 3 customers will make a purchase? So we are saying the probability that 2 of the next 3 customers. So the number of customers we are assuming is 3. So we are saying our n is 3. So out of this 3, they are saying what's the probability that 2 of them, right, will make a purchase, will buy. So our x is 2. This is our total number, and this is our success, like our number of successions. Now, the probability that these 2 people will buy. So first of all, we have to look for those the probability that they won't buy, right? Because it's a binomial. It's either they buy or they don't buy. So if the probability that they will buy is 0.3, then what's the probability that they won't buy? So let's represent it by Q. And we say the probability that they won't buy is 1 minus the probability that they will buy, which is equal to Q 1 minus 0.30, which we are going to get, since it's 1, we are going to get 0.7, 0.70. So we coming back to the question, we are finding the probability that x is equal to 2. That's the probability that at least 2 buy, right? Or the probability that 2 of the next 3 customers will buy. The probability that 2 will buy. And we know our formula is the commutation of what? Nx, probability of x, multiplying the probability of n minus x. So what's our n? Our n is 3. This is our n, 3. Our x is 2. And then our probability that the customers will buy is 0.3. So we have 0.3 here, exponent x, which is x represented 2. So probability of success. And then we are saying 2 buy, so 2, right? So 2 success, and then failure. So the failure is the kill, and we know the kill, that is 0.7. So we have 0.7 here, and then the probability that they won't buy is what? Is the probability that the total number minus the succession. So which is 3 minus 2, definitely 1, right? So we have 3 commutative 2, 0.3 square, 0.7 exponent 1. Versus you punching them on the calculator. So let's do the punching. So when you punch 3 commutative 2, you get 3. When you point this on the calculator, we're going to get this, and this remains the same. So now we punch everything together. So you get 0.189. So this is the probability that two out of the 3 will buy, right? So probability has to represent them in percentage. So you can leave your answer like this, or represent them in percentage. Represent them in percentage. Let's multiply this by 100. So I multiply this by 100. You get 18.9%. So this is the percentage that 2 out of the 3 customers that enter the store will buy from the store. Yeah. So that's our first question. Our second question to tackle here, we said at UGBS, 30% of the students are majoring in finance. In a sample of 10 UGBS students, what's the probability that exactly 3 of them are majoring in finance? And our B says that in a sample of 10 students, what's the probability that at least 3 students are majoring in finance? So let's take the question again and then let's answer them accordingly. So we are saying that at UGBS, 30% of the students are majoring finance, right? So 30% of them are majoring finance. So if 30% are majoring finance, then who are the people that are not majoring in finance? So the probability that 30% are majoring in finance become the success. So we represent it by our P. So we say the P is what? 30%. Which is also equal to 0.3. So if you want those who are not majoring financing, that's our failure, will be 1 minus our 0.3, right? Which will give us 0.7. So these are the ones that are not measuring. So our first question A says, in a sample of 10 UGBS students, so when they choose 10 UGBS students, what's the probability that exactly 3 of them are majoring in finance? So what's the probability that exactly 3 are majoring in finance? We know our formula already, which says that the commutative of n and a is multiplying the probability that the number that they are selected, also times the probability that yeah, so this is the formula. So we just input them, just fixing the values. Our C, our total number that was selected was 10. 10 students were selected, and then they said out of the 10, what's the probability that 3 of them, right? So here is 3, and then our success here is 0.3. 0.3, here will be 3, and then our failure is 0.7. So this is 10 minus 3. So the commutation of 10 and 3 is 120. So we multiply everything here. So we're going to get 0. So let's represent them in percentage. We get 26.5%. So this is the probability that exactly 3 of them are measuring finance. Yeah, so the probability that exactly 3 of them are measuring finance is 26.5%. So we have 26.5% here. That's the probability, right? And then the B says, in a sample of 10 students, what's the probability that at least 3 students are majoring in finance? So here they are saying that they sample 10 students, right? So our n here is 10. That's from 0 to 1 to 10 students that we sample. And then they are asking for, they said our x is what? What's the probability that at least 3 students are majoring in finance? So at least, which means the least one should be 3, right? So it means we have to find the probability that 3 from 3, 4 up to 10 are majoring in finance. Okay, so since we know probability sum up to 1, the summation of all these probabilities is equal to 1, we can say that 1 minus the probability of from this 0 plus the probability of 1 plus the probability of these 2 will give us the probability of you finding from 3 plus 4 up to 10, right? Because assuming we have, let me draw a table somewhere here. Assuming we have this table and it has been divided into 10. So 1, 2, 1, 2, 3. Okay. Yeah, so this is 10. And what they are looking for is that the probability that at least 3 students are majoring in finance, right? So at least 3 students are majoring in finance. So it means they want, starting from this place, all these students here are majoring in finance. So who are the students that are not majoring in finance? This is 0 here. These are the students that are not majoring in finance. From this 0 to these 2, they are the students that are not majoring in finance. So to save time, instead of finding for the probability of this 3, finding for the probability of this 3, 4, 5, 6, 7, up to this 10, we can find the probability that 0 did not, probability that 0 measured in finance, 1 measured, 2 measured, and then we subtract this from 1, right? Because all this sum up to 1. So subtract it from 1. Then the result will be the probability that at least 3 of the students majored in finance. So let's solve it. So we can say 1 minus the probability that 0 measured in finance will be the commutative of 10, and it will be 0. And then we know our probability of success is 0.3. And then those are measuring in finance is 0 here. And then our probability of failure, which means if 0 measures in finance, then it means the rest of the 10 did not measure, right? So let me do a big bracket here. Plus, you can do them separately, or you can bring them like this. The commutative of the same 10 students, probability that they measured in finance is 1. The success is 0.3, 1, 0.7, that's those who did not measure. It's 1 minus the 10, which will give you 9. Plus our commutative of 10 here is 2, plus this 2. Probability of success, which is 0.3. I'll write it here. So let me bring it here. So commutative of 10, 3, 0.3, 0.7, 7. Right. So you find them. So to save time, I'm punching everything into it. I'm punching this, and I'll punch this as a whole, and this too as a whole. So we have 1 minus. So for probability of 0, we had 0.0238. Yeah, so we say plus the probability of this. So give us 0.121 plus the probability of the second one. So here's 2. 2 is 8. We're going to get 0.233. Okay, so 1 minus the summation of this, 0.3768. So minus 1. What we are going to get 0.6232 representing 11%, we get 62.32%. So this represents the probability that at least 3 of them are measured in finance. So probability that yeah. So that's how we solve it. So let's look at our mean, how to find the mean, then the variance. So what we are saying is that to find the mean in a binomial distribution, we just multiply our sample by our probability of success, right? So that's how you can find the mean. That's how you can find the mean. And how to find the variance is you multiplying your mean. So this is your mean, your number of success, probability of success by the sample, right? And then multiply it by the probability of failure. Then you get your variance. So you just the mean by the failure, you get your variance. And then for your standard deviation, just the root of the variance, right? The root of the variance. So based on this question, let's assume our probability of success was 0.3, and then the number of students was 10, right? And then if you have to find our mean, our variance, then our standard deviation, what we were saying is that our mean is equal to the number of sample multiplied by the probability of success. So here it will be the 10, that's the number of samples by 0.3. This is going to give us 3. So this is our mean. If you talk about our variance, we are saying that is the number of the sample multiplied by the probability of success by the probability of failure, right? And then we already know that. Okay, so let me write it here. So our sample is 10, probability of success is 0.3, and now we say our probability of failure. Probability of failure is what? 1 minus our probability of success. This is equal to 1 minus 0.3, which will yield at what? 0.7. So here will be times 0.7. This will we're going to get. So our variance will be 2.1, right? And then our standard deviation is the root of our variance. So 2.1, good, which is going to give us 1.449. So we can equivalent it to 1.5, right? 1.5 as our standard deviation, and then 0.1 as our variance, and this is our mean, right? So this is all for this section about binomial distribution. So I hope you go through it again and then you take notes of some petty things. I'll be solving more questions, a lot of questions, about 6 questions later, and then I'll upload it so you can make reference to those things, and then I hope you all understand. Yeah, so that's all for today.